So let's take a look at applying some of these rules. So taking a look at this graph right here, the first thing I can notice about it is that as I trace it with my finger, there are no gaps, there are no breaks, there are no holes. So this graph is continuous. U-N-T-I-N-U-O-U-S. It has no discontinuities. So it is continuous. What else do I know? I notice that it has a maximum right here, and that maximum is local. So there is a local maximum at the origin. I also notice the graph has a minimum right there. And as I count the squares, that's 1, 2, down 1, and a little bit more. Now you can use technology to get more exact, but at the moment I'm just going to estimate and say that that's about -2, -1.2. That's a minimum because it's the bottom of a valley, but the graph does get lower, so it's local, not absolute. So I have a local minimum. At 2, -1.2. Right? What else is there to say about this graph? Well, I notice that it has an increasing interval right here. Slope is positive there. I notice that it has a increasing interval right there. And here in the middle, it has a decreasing interval. There in the middle, it has a decreasing interval. So just like the last part of the previous video, I'm going to say it is increasing. Now remember, when you're saying increasing or decreasing interval, you're talking about x. So how far to the left can I go and still see a positive slope? Well, as I go to the left, I go down. And I'm going down and down and down, but I'm also going to the left and left. So there's a positive slope here. Folks get confused. Negative slope does not mean go down. Left and down is positive slope. Right and down, like this, is negative slope. This is a positive slope. Just because I'm going down does not mean it's a negative slope. Left and down is still a positive slope. So I have a positive slope as I follow this thing to the left off to -infinity. So x, -infinity, up to, right here at the origin, x is 0. And we also have one here. This is also an increasing interval. So x from, on the left, we have x is 2. And as I follow this graph to the right, it goes up, going to the right, going up, going to the right, infinity. What about a decreasing interval? Well, this graph has a decreasing interval from here, which is the origin, 0, to here, where x is 2. So decreasing, x goes from 0 to 2. And that describes all the big features of this graph. It has no asymptotes, it has no holes, no gaps. We have the maxima. It has a local maximum and a local minimum. We have the increasing and decreasing. We have this continuous. That pretty much tells us just about everything there is to know about this graph. Oh, domain and range. Domain and range. Silly me. So what's the domain? Well, this graph goes forever to the left and forever to the right, so that's all real numbers. And this graph goes forever down and forever up, so that's also all real numbers. Domain and range, all real numbers. All right. Now let's take a look at a second graph. Now here we have a graph that's a little bit more complicated, a little bit more going on here. Right off, you'll notice we have a big gap right here in the middle. But if I look carefully, I can see that it's possible, and sometimes, you know, you want to zoom out a little bit so you get a better look. So I'm going to zoom out a little bit here, and I can see that if I zoom out a little bit, I can see that there is a vertical asymptote right there. So we have a vertical asymptote. Remember, vertical lines are always written as x equals, so this is x equals 1, 2, 3. And I can also see that there is a horizontal asymptote right there. So I also have a horizontal asymptote. Horizontal lines are always y equals, going up 1, 2, y equals 2. So we have a vertical asymptote at x equals 3 and a horizontal asymptote at y equals 2. Now you go back and you look at your notes from the previous video, that means that this graph is not continuous. This graph has infinite discontinuity. So we have infinite discontinuity. What about maxima? Well, do I have a peak of a hill anywhere? No, no peaks of hills. What about bottom of a valley? Do we see the bottom of a valley anywhere? Nope. So this graph has no maximum, no minimum, so it has no extrema. So there's nothing to talk about there. What about increasing and decreasing intervals? Well, let's take a look here. What kind of slope do I have here? Well, it can be kind of hard to tell at a glance. Let me get out my ruler. Let's see here. Pretty close to 0 right there, but it's not exactly 0. Notice if I follow along, this slope is negative. And what about up here? If I follow this along, let's see. You see, as I follow along, that slope is negative. So this graph has a negative slope over here, and it has a negative slope over here. That means it is only decreasing. This graph is only decreasing. And where is it decreasing? Well, let's see. It's decreasing all the way over there. That's negative infinity. To here, that's 3. And then it's decreasing here at 3 all the way to infinity. So that means it is decreasing for all real numbers except, well, where is it skipping? It's skipping where the asymptote is. Because it doesn't have positive slope at the asymptote, it doesn't have negative slope at the asymptote, because it doesn't even exist at the asymptote. There's a gap there. So all real numbers except 3, we have a negative slope. What about increasing? Well, it's never increasing. This graph only has negative slope. And that seems weird. It seems like, how can a graph go down, 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 and then jump all the way up there and start coming down again and never have a positive slope? But math's funny that way sometimes. What else is there to talk about? Well, there's domain and range. And so what's the domain of this graph? Well, again, all real numbers going to the left, all real numbers going to the right, except right here in the middle we've got a gap. So that is all real numbers except where this gap is, and this gap is at 3, just like the decreasing interval. What about the range? Well, now we're talking about y. How low does this graph go? It goes down toward negative infinity. And it comes up, 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 up. How high does this graph go? It goes toward positive infinity. Does it have any gaps in between? Yes. It skips over the asymptote. And where is the asymptote at? It's at 2. So the range is all real numbers except 2. And so there we have a complete description of this graph. We know its asymptotes. We know its continuity is infinite discontinuity. We know it is decreasing everywhere except where there's a vertical asymptote. Its domain is everywhere except where there's a vertical asymptote. Its range is everywhere except where there's a horizontal asymptote. And so now